Okay, hey, zkGM everyone. Today we have Shreyas. He'll be leading the session. Let's give it one more minute and then we can start. And Shreyas is a DevRel at Safe Foundation. And when we start, he can introduce himself. And since he is part of the ZK Monk team, yeah, I'll let him do the introductions. Okay, Shreyas, do you want to go ahead and maybe share your screen if you have a presentation for us? Maybe we should get started. Feel free to introduce yourself.
Hey guys, I'm Shreyas. I work as a DevRel at Say Foundation, and I've been in the ZK space before joining Say, which is I was at Nil Foundation, where we're doing a lot of stuff with ZK, and also been with the ZK Monk team in like organizing this cohort, this boot camp, and all the lot, and all like just the peripherals of all these things. And I'm like delighted to take up a session where, and I'm I'm not a guy who would like to like explain things, but a guy who wants to, like code and make you guys code as well because you guys had like some weeks where you guys like understood a lot of things, but then from this week onwards, we plan to, put that knowledge into code and make sure you start building something. And the main goal of this class would be, or I mean, this session would be that you guys would be basically like, building something that I would like walk you through it and explain how to do things and stuff. All right. Before I start off, right, I just want to know how many of you are on your laptops and maybe have like VS Code installed. Awesome. That's a good number of thumbs ups. Thanks a lot, guys. Oh yeah. So if you have no VS Code equivalent, you can just use code spaces. Let me just type that down. They should give you like enough access to like a code editor and you should like be able to do things. So in this session, I have no presentation. Instead, I have like my VS Code open, which I'll be sharing in some time, right? What we'll be doing, I want to give you like a quick run through like an agenda so that you guys know what you guys are going to do in the next 45 minutes. So what we'll be doing is that we'll be have you guys heard of like ZK email first? Like if you guys could give a thumbs up if you guys have heard of something called ZK email. Yeah, because okay, good. I mean, I'll always be, like starting from scratch on what ZK email is and then making you understand what it does, where it's used, and why we are actually discussing that, and how zkVerify comes in picture, how to use zkVerify, all these things, right? Like from end to end. So starting off, we like since it's been like 5 minutes, yeah, now it's a good time to start. What is like ZK email even, right? Some of you like don't even know about it. So I'll explain you guys. So ZK email is a kind of a technology that lets you generate like zero knowledge proofs about email content. For example, like the sender, subject, or some other metadata without actually disclosing the actual data, right? So it's like proving something about an email without showing the email itself. And these are very important for like privacy preserving verifications. Now, for where now where would it even make sense? Like, why do you think like email should be you want to generate a proof of an email and things, right? It's because maybe you want to attest something that, hey, I did receive this email, but I don't want to show you what is in the email. But yes, like, I have received it. For example, maybe proof of participation scenarios, right? That's a very common use case for this, and we'll be also like looking into that one of those things itself in this session. So zkML in general is a kind of technology that lets you like generate a proof for an email through which you can actually use provers and verifiers without to prove something without actually revealing the data of the email. Now, how is it even done? Or let's not go to how is it done. Let's understand like why should we actually do this, right? As I told you, just like summarize, is maybe you want to prove something about an email without revealing the actual content, or you do not trust that, maybe the server that sent you is not a verified server, or maybe they are like the not right person, maybe some wrong malicious person sent you an email, and now you want to believe it, but you have a doubt whether it's from the right person or not, right? So all these kind of scenarios are something that could be evaded or solved using zk email. Now, how does it even work, right? If you think of, let's get into a bit of tech here, because I don't want to really like explain you guys just in theory or like in general, right? Because I'm gonna make you guys code now. So how does it even work, right? So what would happen is that, let's say you have an email, right? You have like a to, you have from, you have like subject, you have closed cap, I mean, so you have cc, you have bcc, all these other things, right? And also you have your email body, and the timestamp that you sent it, all these things. Now maybe you want to prove only something with it. Maybe you want to prove, for example, let's take a very simple example. uh let's say there is an email that you got from, maybe let's say, there was a maybe let's say that there was a bootcamp from zkmonk itself, and you got an email from zkmonk that, hey, you're selecting the bootcamp. And now you want to prove this to someone, but you don't want to like let them know everything that is in the email, maybe the list of classes, the list of mentors, what is in the program, all these things. You don't want to like send all this data to someone, because not everybody is selected, right? So that time what you would do is you would want to like create a proof of this email, with such that when someone verifies it, they can only get to know whether are you in the bootcamp or not, right? So what you would be doing ideally is you would be generating a .eml file, and we'll like you walk through the code, so you'll like have a better grasp on what I'm telling you, but like just like make a mind map of what is going to happen next. All right. So you'll be generally making a file called .eml, and then you'll be going to the zk email website, and you would have something called blueprints. And what you would be doing is you would be basically creating a blueprint. And what does a blueprint mean is, you have a email and you want to prove only some things in the email, so you'd create a blueprint with such that this is the body. And then you want to like prove, you can give like public inputs, such as maybe the sender, the receiver, and the subject, and the body hash, all these things, right? And then you would give in like some private inputs, uh, through which the prover would actually generate a proof for you. And basically you're creating a template. For example, you given, like as I told you, already gave the email. Now you want to like generate a proof. How do you generate a proof? You need to write a circuit for it, right? But in this session we are not writing a circuit. Instead, uh, we would be like using already one of the pre-programmed circuits. All right. So I'm just like letting you guys know how this process works. You would be like writing a circuit, and therefore your email, through which only those particular sections of the email would be taken as inputs, and then a proof would be generated. Ideally, if we try to do this over, you know maybe this session, it would never be possible, because you have to like submitting, writing a circuit, and then getting it approved usually takes like some days. It is not like done instantly. That's the reason we are going to like use already a pre-programmed circuit, in order to like understand how zk email works. So now, where are we in this journey? We know that we have an email, we put it into .eml file, we submitted, we created a blueprint. Let's say, like, our blueprint gets approved. Now, what does a blueprint actually do? Is it would basically have an email body, and then maybe a sample email body, and then it would have a circuit, which the circuit would basically pick the fields from the email body, and then use those inputs, and then generate a proof for whatever you ask for, right? So that we have come till now. Now we have generated a proof that's good enough. Now, how do we verify it? Right? So for verifying this, we use zkVerify.js. zkVerify.js is nothing but a client library from zkVerify team, using which you can actually, uh, you know, uh, let's say you have a proof and then you send in like some other public inputs that are like used to generate the proof. zkVerify.js can actually verify it and tell you whether it's, like whether your proof and the public inputs are right or wrong, whether, you have the authenticity of the proof or not, right? So that is where like zkVerify.js comes in. And there's a bunch of things you have to do with zkVerify.js, and we will be like doing all those things. And once that is done, like we'll get to know whether it's a legit proof or not. So this
Sorry
process
to
is
interrupt, but do you have a presentation?
no, but I'll be
Like a
like
screen?
that. I'll be now sharing the screen.
You will be or you won't be?
I will be like I'm about to like share my screen
Okay,
now.
great.
Yeah.
Thanks.
I just wanted to give everyone a small mind map on what we'll be doing. Yeah, guys. So you guys can see, right? My screen. Can someone like, maybe awesome. Uh okay. So I want to like show it. I mean, I want all of you guys to, like open up your editors first. And then, just give up a small thumbs up once you guys have opened the editors. Awesome. So if now I'll be like showing you guys in code first on I'll give you like a walkthrough on how what we'll be doing in the code and process that I just mentioned before, so that you get like a much better grasp on what we are doing and how to do things. Because what I believe is when you're trying to build something, it's more on the pattern on how you build things rather than like actually coding things, right? So we'll be like going through what this is, and then all of us would be like going word by word. Like I'll code with you guys and you guys will code with me, so it's like a live coding jam session. And then we all will like try to generate a proof and then prove it on the Volta testnet, that is like zkVerify's testnet. All right. So as I told you, we need a blueprint initially, if you guys remember, right? So we use this particular blueprint, which is basically the sucks and zk residency invite, and we can actually go to that and check what it actually is. uh Let me just like think, what was that? Email print. And also, if you guys want to like read through this, there's also a page for it. It's directly in the zkVerify docs. I want to share that as well with you guys in the chat, so that if you guys are not able to follow up with me, you guys can actually read this. Yeah, let me show you. They have somewhere which actually takes you to the right page of, yeah, easy camel. This is the one I was talking about. So this is like a list of zkML blueprints. So as you can see, this is like an email for like Binance account, for Binance KYC, Instagram account, Apple ID. Yeah, there's just like bunch of things that people have put in, and we'll be using one of them, which is the Succin ZK residency invite. And we would be like, what we'll be doing is we already have a .eml file here, which basically is you would actually get this .eml file. How do you get this? Is if you like are sending a mail to someone, you can actually go to like the three dots above and then like press download and then like choose like .eml file as your format to download, and you would get this thing. I mean this kind of file. I'll be sharing this file as well with you guys, so I'm just like let me search. I think this should be present somewhere in the docs, or yeah, this is the file. I've pinned these two things. I'll tell you like where we need this and then what we'll be doing with this in some time. All right. Awesome. So let's go to the code now. So what we'll be doing is we'll be first like using the zk email SDK. We'll be using two SDKs, zkVerify.js and zk email, and we'll be like using get blueprint, which is basically this would go and then get this particular blueprint, which was created by the user called BISHT13, and the name of the blueprint is this. And what this blueprint usually is, again, is an event template along with a circuit associated with it. All right. And this is something that was developed by this particular person. You guys can actually create your own templates as well for if you want to like prove some emails. But again, that's going to take some time, which would be like more than what this session is planned for, or like a lot more than that, to be honest. So yeah, I'm not keeping that in scope for now on how do you build a template yourself, but instead, yeah, you will be basically like trying to use a already pre-programmed template, and then you would get like the verification key and the prover key. Or so I hope you guys like have attended the previous sessions where people would have explained about what is a verification key and what is like a prover. In simple, prover is someone who would be you know uh like it's a set of code that would let you take all the inputs and then what you want to prove and then generate a proof for it, right? And verification key is like a kind of a middleman which would be used to actually create the proof, and the same verification key would also be used in your proof data for verification. All right. And then we basically initialize both of these, and then we use like we read the file, which is like common, and then we use like the generate proof function from the from the prover class, which is from the zk email SDK, and then generate a proof. All right, we'll also like try to see what the public signals are and try to relate them to what they mean, so that it would be like a much easier way to understand. And what until here is the proof generation part, and then zkVerify.js is so simple. I wanted to show you guys this. It just takes like maybe 20 lines of code with formatting for actually verifying the proof. So all I did was like I started a new uh just a new instance of like zkVerify. They call it session is nothing but you're basically connecting to the Volta testnet. That's all. So I do like the dot Volta is basically the testnet name. And then this is my seed phrase, which is a burner wallet. So if you guys like take something as well, yeah, I'm fine with it. uh and then we have events. So what would happen is we are like over here we are trying to like generate a simple connection to the Volta testnet. And Volta testnet is a Polkadot parachain. So that's the reason we don't use Ether. Instead, we use this kind of connection type, or like the syntax for connect. And then what we'll be doing is we'll be like posting that particular proof that we got along with all the other data. And then we also tell it like what is the palette, which is groth16, because this particular uh, circuit is built on groth16. And then the library used over there was snarky.js. So we use snark.js. If you by any chance use a different template, make sure that you change these things particularly. Is it like groth16 or is it another some maybe arcworks or maybe gnark, right? Only these three are supported. If you like, you guys can check them out somewhere here. Yeah, like plonky to all these things, right? So you guys have to check what is the circuit built on, and then you would be sending the same palette here as well. And then for library use, you can see here like they use either gnark, arcworks, or snark.js. And then you would be sending that library as well. And why we need to do this is so that you can actually verify it properly. Otherwise, you're just sending in the wrong data for the chain to verify. And then we basically here to events, which is this is like an on-chain transaction. So once you do this transaction, you have an event, and apparently zkVerify.js also like gives you this particular uh things in its library where you can actually directly listen to events without like doing much of the things. And once you like have this dot included in block, which means it means that you have actually sent everything and it has verified whether it is true or false. And then we basically like console log it and see. All right. uh if you guys like got a proper mind map on this, I would like to like start building from scratch, and I want you guys to jam code with me. I just want to see if there are any thumbs ups, if you guys are ready to jam or like code jam with me, or oh, just one. Okay. Okay, more are coming in. Thanks a lot. Awesome. So what I want you guys to do is let me start from scratch. So I want you guys to like create a new directory. Uh let's say zk camp, and then go inside that. And then now let's like like if you guys like want to actually, if you're like maybe being a bit slow or something, you can just use this because I've literally built based on this particular document to make sure you guys don't get like confused. And yeah, you just have to like initialize first an npm project, and then install the zk email and the zkVerify.js packages. This is going to take a bit of time, so yeah, I want you guys to like follow up quicker a bit. Also, in the meantime, I wanted to ask you guys, have you guys by any chance downloaded any wallet that supports Polkadot? Maybe a thumbs down or thumbs up would help me to understand, because there is a step. Yeah, okay. Okay, that's good. So people have not done it. Let's do it again. All right. We'll get there. We'll get there in some time. We'll try to like install Polkadot wallet. We need it because we need some funds to actually, send this on chain. Now let's just open our code editors and then create a simple file, index.js. And then what are some things that we did over here was uh, you guys can actually that I've like shared, but again very similar. So we'll be like basically importing all these zkVerify session library, curve type, all these things from zkVerify.js, and then we will be there. Now we would be importing something called uh no, it's initialize zkML SDK. If you see here, it's called just zke SDK, but this is something that is changed recently in the zk email uh SDK. So it's not like zke SDK anymore. It's actually init zk email. Okay, yeah, init zk email SDK. This I've already raised a PR for like changing those things in the zkVerify docs, so those should be changed soon. But yeah, like if you guys are following me, you guys should get this. And then once that is done, I'm gonna like make sure to show you guys that I'm actually following this particular code snippet so that like you guys can do it anytime. And then post that. Okay, let's actually do one thing. Let's actually set this up a bit. All right. So now we'll be like initializing the SDK, which is init zkML SDK. If you guys here, they've used like zk SDK, which is wrong. Uh, and then once we do that, we get the blueprint. So what we'll be doing is we are telling the SDK to go to the server and then get the blueprint for this particular one, which is something that I'm gonna like put up in the call over here as well, so that you guys can just like copy paste this. But again, yeah, I'm actually following through this code snippet, so you guys can actually try this out anytime you want. And then we use a verification key. So what? Somebody got a doubt? Oh yeah, go ahead. Like conquest. Like I see you've raised your hand. Like what's this you pasted here? Okay, so this is basically the blueprint that we would be using in this particular example that we are trying to build. And basically we are like trying to we are like trying to like call the zk email registry that, hey, I need this particular blueprint, uh because because we'll also be like using a .yml file in some time, where what we'll be doing is we'll be using this blueprint and then that .yml file and then trying to generate a proof for it. All right, this is just a blueprint. And what is a blueprint? It's just a template which is an email along with a circuit along that comes along with it. You like, if you have any doubt, like, yeah, I'm like happy to answer now. Or if you have like understood, maybe like put up a small thumbs up. I'll just go ahead.
So I understood. I understood. You can carry on. Thank you.
Yeah, so Love Gupta, we can actually use different ones as well. Like, you're free to use them, but then just make sure when you're using the different ones, you have to know which palette it is using, which library it is using, and the curve type that it is using. And when you know those things, and you have like example email for that particular template, yeah, then you like go forward and do it. It's I'm more than happy. But yeah, like since I have like uh example for this particular template, that's the reason, I mean blueprint, that's the reason I've just taken this up. And yeah, so let's go get the verification key. Blueprint excuse me. Cool, so we have the verification key now. And then the next thing we need to do is we have to create a prover instance. So we also like ask the blueprint to give me a prover instance. And once we have this, the next thing we would need is the email file, right? So where do we get the email file? I've sent you guys, I've like pinned something over here. You can actually like go to that particular page and that would show you this particular email, which is of the type of the succinct zk residency invite. And since I have this example is the only reason I'm going to use this particular type, right? If I actually had like an example for a different type as well, I would be also like showing you guys another another blueprint and then how to verify it with it. But then at the end of the day, what happens is you would be at max changing the blueprint name and the .yml file, and the rest code still would remain the same. All right. So let's go download this. Yeah, we can just go download the raw file. residency.eml zk bootcamp. Yeah, we have the residency.eml here. So now let's read the file. EML format is defect. And then the next thing should be, well, let's actually rename this. And the next thing would be to generate a proof. Await prover dot generate proof of EML. So now I want you guys to like understand this one simple concept, which is what are we doing here? Like exactly is we already have the blueprint, and this blueprint is something that contains a lot of things. All right. So from the blueprint itself, we are going to like fetch the prover. This prover would already have like the public inputs and stuff. All right. And to the prover, we would also be like sending this particular email file and asking it to generate a proof. And what the prover would do is, since it is from the blueprint basically has a circuit. And this particular circuit already comes in with what are the inputs that it has to take and what palette it has to use, and then what it has to like generate a proof for, right? So we'll be basically calling the zk email server with our eml file and telling it, hey, this is the file and this is the blueprint, because the prover is from the blueprint, and this is the blueprint, so please generate me a proof for this particular blueprint and for the file given. And then you would basically like get back a response which you can console log, and then see what the proof is, which none of us would understand what the proof is, because it's just like hex strings. So until now is where like we are like trying to prove. So you guys can actually try to run this file once, to just like see what the proof is. And this is going to take some time because it has to like basically go to the server and then like generate a proof and come back. So it both depends on like our internet and the load on the server. Awesome. So this is basically the proof. As I told you, uh, it did actually, taking what the title was and then what the description is. This is basically from the blueprint, right? So since the prover is a part of the blueprint class, you can actually see all of these things here. That is, this would prove whether you are invited for the Succinct zk residency or not, and then who it was from, and then you can like see a bunch of things, and then what are the public inputs. So if you guys are like a bit curious on what the public inputs are, it's basically nothing but the to field, from field, uh, and then the body hash, which is basically what the body is. It's like the and like the Kachak 256 hash of the body. All these things basically it's like the commitment. You can't actually see like the actual data here because they're all nothing but commitments. All right. So the public inputs are nothing but the commitments of the data inside your residency.eml. And then you see the protocol that was used was groth16 for this particular blueprint. So you would be using groth16 to verify as well. And yeah, so this is like a console log that you get for your proof. And now let's go, now that you guys can actually create a proof, let's go and verify it, right? So for verification, you need to, as I told you, you have something called session, which is basically connecting to the zkVerify volta testnet. And yeah, const session is equals to await zkVerify session dot start dot, we are going to like use the volta testnet, not any custom testnet. You can actually use like ethereum and arbitrum as custom testnets, but yeah, for now we'll just like stick with the volta testnet with account. And then now here we have to input the seed phrase. All right, now let's stop coding for some time because we need to like set up a few things. For everyone who actually told, they're not able to, they don't have like a Polkadot wallet, I want you guys to do this, which is, let me show you. There's a page. Yeah, like I want you guys to head over to this page. What this page does is it basically gives you a faucet for your volta testnet. But then to get the faucet, you need a wallet like Talisman. So the first thing you guys have to do, I'm giving you like maybe 5 to 6 minutes of time. Uh, Install like the Talisman wallet, set up your wallet, and then make sure you store your seed phrase safely and don't tell anyone about it. And then and also yeah, copy that into your notes or something, and then I want you guys to like give me a thumbs up once that is done. Or actually, you know what? Let me also do with you guys. That would be much easier. Yeah, I'm gonna like do with you, follow on with you guys on what to do so that, yeah, like if you guys are on the same page, you can ask me questions. So if you just give me a thumbs up if you guys are at this page, please. Or also if you guys are actually like doing this, okay, awesome, nice. Nice, people are actually doing. Thanks a lot. Uh, so yeah, if you guys are on this page now, all you have to do is like add account, and then since Volta testnet is a parachain, we need a Polkadot account, right? So press on Polkadot, give whatever name you want, and then once you get the seed phrase right, just like copy it. Skip verify. If you want to verify, you can verify, but I'm like going to skip verification, and I'm gonna like, you have to like use the seed phrase inside the with account part, because this is your like wallet, right? And you also need some funds now. So if you go back to Fossey and the link I like sent you guys and reload once, connect wallet, it actually detects Talisman. You have this particular account, ZK Bootcamp, which is the Polkadot account. Connect, and yeah, so this is connected now. No, it's not connected yet. Yeah, it's connected. Awesome. It's a bit buggy. Yeah. Then we have to finish this. And then claim tokens. This would show that, it's still processing. Okay. It might throw an error, but don't worry. You would usually get your faucet. All right. Because I face the same issue, but then yeah, don't worry if you guys get an error. If you guys have done this. Awesome. It's finalized. I didn't get an error. Yeah. Once you have downloaded the wallet, yeah, like, did anybody have any question? What am I Talisman wallet? Polkadot. It's Polkadot because the Volta testnet is what do you call? It's a parachain on Polkadot. That's why you have to choose the Polkadot network. So yeah, guys, like I'm gonna give like maybe 2 more minutes, and I want to like if you guys have done, just give me a thumbs up that done meaning you guys have like received the faucet, or like you guys basically are on this page and then you see like finalized in block. When I'm clicking on connect wallet, it's written to. Oh, okay. Just reload once. Just reload the faucet page once. Then it would detect. All right, guys. 1 more minute because we're also running from time. All right, I'm gonna go ahead now. Uh, so once you guys have the faucet, right now, come back to coding. Let's go. Let's finish this thing up. So what we'll be doing is now that we are able to like we have this particular code snippet that would connect to our Volta testnet. Now what we have to do is we need to post the proof along with the public inputs and the other proof data to the chain so that we would get to know whether it's verified or not. All right. And how do we get it? How do we get to know whether it's verified or not? Is by using events. So let's basically do that, which is events is equals to session dot verify. Now the session already has your account with it. So it's like if you think of if you're an Ethereum developer, you can think of it like you're connecting to the provider with your wallet, or you're connecting to a contract using your wallet, right? So in ethers we do something like ethers dot provider, I mean JSON RPC provider, and then we send in the RPC URL, and then we do like ethers dot wallet, and then give our private key and the provider, and then we do ethers dot contract, and then try to instantiate the contract with the wallet itself, right? So over here we are doing the same thing. That's all. Like we are just like using our seed phrase to connect it to it so that we don't have to sign something anywhere. So what we'll be doing is we will be like calling session.verify, and for that we need to send in the palette. And the palette that it used, if you guys saw previously, was grot16. And inside that we need to send in which library it used. So the library was basically snark.js. Yeah, this is something you'll get to know if you like go through this particular blueprint in detail. You'll get to know like they use snark.js, and then we need to also send in the curve. So the curve would be BN128 because grot16 is like BN128. And then we need to tell it like, hey, execute this and send in some data to it. For example, uh, sorry, proof data, which is like an object, which is we need to send in, wait, yeah, the verification key that we get from the blueprint. So using parse and then we need to send in the proof data, and then the public inputs. So I'm just like basically following this particular guide. So if you guys are like lacking anywhere behind, you guys can actually follow that guide and you can come to where I am right now. And once we do this, we are basically now submitting a transaction to the chain with your wallet that you just got a faucet from. And then you are going to like, listen to the events. If you guys are like, again, Ethereum developers, you guys would be used to this dot on method. So what we're doing is we are basically included in block, meaning it's finalized, right? So we're going to like listen to an event once it is finalized, and then event data, and write a small function for it where we try to console log what is included, and then we do session dot close. Basically, we are like trying to get event data, meaning like the transaction receipt of it. That's all. Session dot close. Okay, we're actually yeah, let's console log like session closed. Cool. So now what we'll be doing is, until now we have like already generated the proof ones. You guys can actually see, you guys generated a proof now. But now we are like going to like submit this to Volta testnet and then ask it to verify it for us. And what is it verifying? It's going to verify using this particular blueprint and REML file, the proof that is generated, right? It will be verifying that whether whatever the verification key is that is mentioned in this. And as far as I know, the verification key is whether does this email tell whether a person is accepted into the Success ZK residency program or not. So that is what we'll be going to verify. So yeah, let me just clear. And this is gonna take some time, but yeah, like let's just like maybe a minute or a minute and a half. And in the meantime, if you guys have any doubts, like please ask me. So this was the proof. We have console log the proof, so that's just appearing up again. Also, awesome. So the session is closed, which means it's included in block. Now let us go to the zkVerify Volta testnet explorer and then use the transaction hash and get to know whether our proof is a right proof or a wrong proof. All right. And the explorer also is available here. Let me actually put that up for you guys. Awesome. So this is actually, what do you call, like we did submit it to the testnet and then we got our proof verified and the result was success, which means, it's the right proof, which means the particular email actually tells us that, yes, this email is legit, which was sent from Succint, and it me and also the data in the email, or the proof that is generated for the data in the email, is that this person is selected for the ZK residency is invited for the ZK residency program by Succent. So if you guys have done till here, I want you guys to like maybe put a small thumbs up. Awesome. We got some people actually doing this. Some people actually verified things on the testnet. So at the end of so this is like a small demo that I wanted to like share with you guys in this class. And I want to like summarize again, because as I told you, I'm a believer who thinks that while you're building something, it's more about patterns rather than just sitting and coding, right? So how does this pattern look? Is you first get a blueprint. The blueprint contains your template email and the circuit, which is already pre-programmed. You can also build your own template and your own circuit, but it's just going to take quite a good amount of time, which was not feasible in this particular class. And then once you get your blueprint, you would be basically extracting the verification key and the prover out of it. And once you get the prover and the verification key, you would be using your already existing EML file and then sending it to the prover to ask it to generate a proof for you. Once you generate a proof for it, you would be you get a proof for it, right? And once you get a proof for it, you would be basically starting a connection to your Volta testnet using your own account, using the seed phrase. And once you do that, you can actually execute the verification on chain by telling it what are the palettes that are used and the library that is used, and by sending in the proof data, of course. And then you can monitor for events. And once that is done, you can you will basically get the event data, which is basically all these things here. And you can take the transaction hash, go to the explorer, and see whether it's verified. It's a verified proof or not. So this is like a pattern to work with zk email using zkVerify.js. And yeah, that was like the scope of the class that I wanted to do for. I mean, do things for. And then yeah, if you guys have any questions now, I'm happy to answer.
Can I
Yeah,
go?
please go ahead.
Okay. You've shown us the JavaScript library for verification of ZK email, or does it have a Python library?
I don't think so. There's a Python library existing. zkVerify people, as far as I know, they have a JS library. But it's worth checking. But yeah, as far as I know, it's just like a JS library that they have. Awesome, guys. You guys have maybe 2 more minutes before I can give it back to Anne for some closing notes. And yeah, by the way, once you have since you've attended this session, right? I want you guys to actually do this maybe in your free time, or if you're interested in learning more or experimenting like me. Is that Oh yeah, Cryptosaurus, go ahead.
Yeah, hey Shreyas. Uh, I'm just curious how zk Verify can be implemented in gaming, like if you're building a game.
Oh,
And
interesting. Yeah, so how zkVerify.js can be used. So zkVerify.js is just a library through which you can verify any given proof. All right. So with any given proof, you can actually verify it. So what you can do in gaming is maybe somebody wants to prove that they are at a certain level, but they don't want to tell you what level they are in. So you can use some other circuits to actually you would have to write a circuit on your own for generating a proof where they can tell that hey, I'm at a certain level, but yeah, just don't reveal the level, right? And then you can take the proof that is generated over there and then use zkVerify.js for actually verifying it. So yeah, zkVerify.js is a very general purpose library rather than where, it doesn't have a niche, right?
yeah,
So
I asked because I recently saw that there's a Space Invaders game zk Verify has released. So I just wanted to say, how did they implement zk in the game?
yeah, as far as I know, I think oh yeah, I think I know about the game. uh I don't specifically know where they implemented it, but then some of the very general use cases that I have seen in games where zk has come into consideration is while they want to maybe open a crate, or maybe and then they don't want to let a lot of other things know, and they want to just prove that they're eligible to open a crate or earn something in it. then they generate a proof out of it, and then you can use like zkVerify.js to verify it, right? So this is like a common scenario that I've seen in games, but then I don't know like what the people who have built the game. Even I know about the game that you're talking about, but I just don't know like where they've used zkVerify.js on what to prove.
Okay, bro. Thanks a lot.
Awesome. So yeah, guys, just like some closing thoughts, which is I want you guys like since it's about like I took a class on zkMail, I want you guys to try out like different blueprints, go through them a bit, and then play around with a bit with this code snippets, which is already available to you in the what do you call like in the chat that I've sent you. And yeah, just play around and see where things break, because that's where you can start contributing to, right? So yeah, that's all from my side. And if you guys like have any doubts, I'm still like around. And if nobody has like, and I would like to hand it over to you for some closing thoughts.
Yeah, thank you so much, Shreyas. That was great. I hope you guys learned something today. Shreyas, if you have some time, maybe we could head over to the Discord channel, and if you guys didn't get a chance to ask your questions, maybe we could continue the discussion there, and Shreyas could answer them.
Yeah, I would be happy to do that.
Thank you so much. Thank you so much for your time. Thank you, Shreyas, for the wonderful presentation. And we will see you next week for another session of Bootcamp. And don't forget that the hackathon will be coming up, and there will be prizes. And we'll be sharing with you the distribution of the prizes very shortly on our Discord and Telegram channel. So stay tuned for that. Thank you, guys. Have a great rest of your day.
Thanks a lot, guys.